In this module, we're going to talk about processes. Any Unix program that's currently running is called a process, and each process gets a process ID, sometimes called a PID, a PID. You can run processes in the foreground and in the background. So for example, here I have a C file I wrote, and I just catted the binary file. So here's the C file. It's just a infinite loop that prints a number. So when I run that program forever, you'll see that it just counts and counts, and it'll keep going. Now the command to show the currently running processes is ps. And so here you see that bash is running and also ps was running because it was running when the command did. You don't see forever here. And the reason is because this is only showing the processes in this particular terminal. If I do ps-f, I get a little more information, including who owns the file, the process ID information, or the parent ID information, and some other things about it. And if I want to see every file running on my system, I can do -a or capital A or -lowercase e. Either one will work. And so here you see I'm getting there's a lot of processes running, different users. So here we have the root user, GDM. With my username, there's several running. Also, this is why you want to be careful that you don't run a command that requires a password, because if someone does ps, if that password is part of the command, so let's say I do something like run command username password, and so let's say my password is password1, that would actually show up in the ps command. So you definitely want to avoid doing something like that. So let's try to find my forever process. So I'm going to pipe the output, and then I'll grep for forever. And so there you can see it's running, and here's its process ID, here's its parent ID. Now I want to stop this, and there's a couple ways I could do it. I could just do a Control-C in the window, and that would stop the execution. I can also use the kill command, and kill takes some numeric that indicates how hard to try to kill. It basically ranges from asking nicely, which would be, let's say, -1, to -9 would be just kill it. So I'm going to kill this process, and you want to make sure you enter the right one. You might accidentally kill something you don't mean to. And you'll notice this command just stopped. So I can try it again. And notice it didn't, because now there's no such process. This is a new process. So I'll need to look for it again. And I can see, there we go. So I'm going to I'll kill that one with a -9. Or let's do -3. So you can see there, the file stopped. Now, whenever you see this core dump, that means that that the file exited and that the memory for the program is saved for you, and you can go in and look at that. We'll likely do that later in the semester, but right now we'll just know that it stopped. Now, if I'm running in this terminal, I could do a Control-Z. Control-Z stops the process, but it's still running. And I can use the jobs command, and the jobs command does show that particular process is stopped, but it's still in memory, so I can restart it. So if I want to restart it, I use the FG command, foreground, and you'll notice it stops, or it starts back up. I can do Control-Z, and I can do this as many times as I want. And again, each time if I say jobs, I can see that job is running. I'm sorry, that job is stopped, but it's still in memory, and I can start it at any time. And then Control-Z or Control-C will stop it from running. Okay, going back to the PS command, I'm going to grep for command or processes that I own. And so you can see there's several different processes. You'll notice there's two separate bash processes. And if I look at this grep command, you'll see it's process 16915, and its parent is 10818. And if you'll notice here, this bash process has the process ID 10818. That's the parent ID of this PS process. So that means that this is the bash shell that's running in this terminal. And that's what I use to execute the PS command. Now, if I want to see what commands are running and how much CPU they're taking, I can use the top command. So let me run forever over here. And if I give the top command here, you'll notice it's telling me that right now, forever is using about 34% of my CPU. And you get a bunch of other information up here that gives you how much memory you're using, how much memory you have available, and just different things about the processes. So for each process, there's different states that it can be in. It could be interrupted, it could be sleeping. And then there's a special kind of process called a daemon, and a daemon is a process that's running in the background, and it's a system process. We'll talk about how to create those later in the semester. But for now, just know that they exist. Two things that we forgot to bring up last time. Let's say I have two files, classes.txt or class.txt, people or teacher.txt. And let's say we have CS101, CS110, CS205, CS240. And then let's create another file where it has Smith, Jones, Huber, and Breeze. So I can use the paste command to put those two files together. And then I can do a redirection to a file. And if I cat schedule.txt, that's there. Let's say I want to add another class. I can actually use redirection again. I can echo CSC, let's say 310, like this, and then I can do two greater than signs to schedule.txt. Now if I cat schedule.txt, notice it added the new class. So this is useful for if you want to continually add to a file, say each time a program runs. If you append, if it's not there, it'll create it, but if it does exist, it'll add whatever you're redirecting to that file.